Today's webinar is a different format than our usual webinars. This will be a question and answer session between myself and Patrick, our CTO. So let me introduce our featured speaker, Patrick Vinton. Patrick is the Chief Technology Officer at Analytics8. Patrick has over 20 years of experience in all aspects of BI rollouts. He has worked in over 100 BI environments in every major industry and co-authored 4 patents related to BI report development, SQL generation engines, and BI application server scalability. And with that, I'm looking forward to hearing from Patrick, or hearing what Patrick has to say. So Patrick, let's jump right in. What kinds of trends are you seeing out there in data and analytics right now?
Hey Howard, thanks for the question, and thanks to everybody for joining. So, and also thank you for a softball to get us started off here. So, some of the trends that you've been hearing about and reading about, we're seeing the same things too. So probably not a whole lot of surprising up front here. The most significant movement that we're seeing is the movement to the cloud, and really our customers truly adopting the cloud in earnest. So customers are using more cloud-based resources, more and more for storage. They're using them more and more for compute power. Like I said, just basically adopting it across the board in earnest. We've seen a real strong uptick here in the last couple of years, but specifically the end of 19. So I'm sure we're going to talk about more of this in a little bit, but with the proliferation of data and accessibility of these platforms, I don't ever see the slowing down or ever turning back. And we've been in the middle of this cloud movement for several years now and guiding our customers on their journey there. And so during our tenure in this world, we're seeing a pretty even split within our customer base of people using AWS versus Azure. But we're continuing to see a small spattering of GCP or Google Cloud Platform. So again, probably not a whole lot surprising there. Perhaps it may be surprising to you to hear that Azure has about, at least within our customer base, roughly half of it. So when you read some of the industry magazines, you see a much heavier adoption of AWS. But it seems, though, at least within our customer base, it's more even when we talk about the adoption of cloud for data and analytics. So that kind of covers the IaaS part of the cloud. And by IaaS, I mean the infrastructure as a service. And again, that's probably not too surprising. But what we are seeing that might be a little more surprising is a stronger interest in the adoption of PaaS or SaaS offerings. And by PaaS, I mean platform as a service. And SaaS, the old moniker is software as a service. I'm kind of blending those two together because, frankly, the lines between the two of those are getting kind of blurry these days, and that's a good thing. And more specifically, I'm talking about products like Microsoft Power BI and Snowflake, and the more turnkey offerings that are cloud-based, but unlike the IaaS offerings that require customers to go in and deal with the lower level components of AWS and Azure, PaaS and SaaS offerings are usually insulated from things like the underlying operating systems and how you're going to store files and the intricacies of distributed computing and backups and that kind of lower level stuff. So that kind of covers the cloud thing, and also with cloud, but also with on-prem installations, we're continuing to see more and more interest in subscription pricing.
So why the trend towards the cloud, and what's the big business benefit?
Yeah, good question. I mean, there are accounting reasons, the whole OpEx versus CapEx, why accounting and budget owners prefer subscription models and, consequently the cloud. But above and beyond that, customers really like the flexibility to start small and prototype things and build a proof of concept and then at that point either cut bait or move on and scale up from there. So one of the phrases I really like to hear, I certainly didn't invent it, but it's the notion of failing fast and fail fast, and that's exactly what I'm talking about here. So you can just, with a few mouse clicks, you can prototype something, and if it works, great. With a few more mouse clicks, you can scale it out to the mouses. Also, with a few other mouse clicks, you can just cut bait and move on. So it's cool. It really does foster rapid innovation, and then because of the nature of cloud resources, coupled with subscription-based licensing, then you can grow as fast as you'd like. So in summary, businesses like the ability to take low risk with relatively inexpensive gambles.
So how's the whole, with today's climate, with everybody working from home, How is the whole move to the cloud enabling that, or just working in that environment?
Right. Yeah. So right now, more than ever, having nebulous resources somewhere in the cloud is very attractive. So unless you're a cloud provider like Amazon or Microsoft or Google, you don't need to have people working in a physical room right now when everybody's been told to work from home. So your workforce, and we're talking, when I say workforce, I'm including admins, but end users and admins of all flavors, they're able to work remotely anywhere. And while this wasn't historically a primary driver for people's adoption of the cloud, certainly it's very much top of mind right now. So it's a good question. So, I think extrapolating upon that, something that we've seen over here over the past few weeks is even companies who resisted remote workforces, they've discovered that they can continue to be productive with a remote workforce, and sometimes even more so than before. So, this remote accessibility to resources, server resources is a must now. And again, I don't see that slowing down for the foreseeable future either.
So with the cloud movement in place before everything, all the recent events have happened, how are companies' behaviors going to change now regarding data and analytics?
We kind of had a dress rehearsal for this in the not so distant past. We in the data analytics industry, if you turn the clock back a little bit to the global financial crisis of 08 and 09, we saw two main themes back then. One was deal with a known and trusted entity. And the second one was do more with less. People had less money and less resources at their fingertips, but they had to do at least the same or more with that. And that sounds kind of simple on the surface, but it can mean many things. So if we dig in a bit, do more with less simply means run more efficiently. And so a couple easy examples include, maybe how do I retain my market share with less marketing spend? What that means is more targeted and more effective campaigns. And it probably also means more dedicated sales focus and, more importantly, a sales execution. Another example might be increasing your productivity with the same amount of workforce, or at least maintain it. So that means you've got to improve your operational efficiency. I could go on and on, but you get the point here. And I think all these examples that I've just rattled off, those are good examples of descriptive analytics. Some people will call that traditional BI, and not surprising that they're all hyper dependent upon a good data foundation, and then the downstream proper analytics for the corporate masses. A few more do more with less examples could be a little more sophisticated. Some examples that we remember seeing before is, improving the uptime of a plant or a shop floor or manufacturing equipment, knowing when certain things need maintenance before they fail, or predicting product failure on time arrivals. So, those are kind of more sophisticated examples of predictive analytics, but we could even take the examples I gave earlier and expand upon those. And that would be something like, predicting what types of customers or even what customers and what industries are going to be most right for your offering. Who's going to be most likely to respond to a campaign? And so these are, again, examples of predictive analytics, and these are most often driven by some sort of artificial intelligence or machine learning or something under the umbrella of data science. And then comes in prescriptive analytics. And so again, when we talk about doing more with less, let's talk about prescriptive analytics. So if we go back to that situation where you may have you've identified a customer who's most likely to respond to a campaign, well, that's great news to have, but now you got to know what you offer them. Or once you've identified an at-risk customer who might leave you, what specifically do you do to retain them? So, I've kind of, when talking about doing more with less, I started talking about some different flavors of advanced analytics. I kind of went off on a little bit of tangent, but since I went there by accident, let me go ahead and just expand upon a point real quick. Advanced analytics and data science doesn't just mean predictive and prescriptive analytics. That's a common misconception out there. Advanced analytics, and especially like AI, can also mean profiling and combing and searching your data and looking for patterns and anomalies, both good and bad anomalies. But it means looking in places that you wouldn't even think to look or even be able to look, or your brain really can only comprehend so many dimensions at once, so you may not even know to look there. So AI and some of these advanced analytics can look across and look in the crevices of the data to improve operational efficiencies. And I think with that, maybe we can go on to the next one. Hopefully, I feel like I'm beating a dead horse a little bit, but hopefully that helps answer your question.
Yeah, good job. Maybe take a little drink of water too.
Yeah, thanks.
So basically, you think that the do more with less trend is pretty much it for the industry's response to COVID-19. It's pretty much going to be the same response as the global financial crisis in 2008 and 2009 is what I'm hearing.
Well, actually, no, I'm glad you brought that back up, because no, I think people are going to play the safe game for a while, and they'll continue to. They'll be less risk tolerant than they would be, even a year ago. So I think, dealing with trusted entities and trying to do more with less, I think that's going to be there. But I do think some things are going to be different this time. I think this time around, people are going to dare to step out on a limb a little bit more than they did the first time, and actually do some innovation this time. And I think there's three main reasons why companies are going to do that this time around. So unlike a decade ago, we already talked about cloud resources. Companies now have disposable and very low risk, but also very powerful compute resources at their fingertips in the cloud. Number two, companies also now have several new, very, very approachable AI and machine learning tools out there, and those things just simply didn't exist a decade ago. Of course, data science existed a decade ago, but not in the format and as so accessible in modern software tools like they do now. And I think the other thing is cultural. I think back then, those AI and machine learning, that was kind of cutting edge, but now that's mainstream thinking. So those three things together, I think this is why we're going to see people doing more innovation this time rather than just playing it safe. Another thing that I think people are going to be doing more innovation these days is because people realize there's more data around this time than there was a decade ago. Companies have more internal data. Over the past decade, they've modernized their internal systems, and so consequently, they have more data of their own data at their fingertips. But there's also more data outside the company walls that they have to draw upon. Here's a good example, kind of in light of current events. Think about some of the reports that we first started seeing as this virus was spreading across the globe. When we first started seeing those reports, they were raw numbers. It was just counts. That was interesting, but really what people wanted to know, at least the next logical thing people want to know is, okay, counts are interesting, but tell me about the rates of exposure, the rates of infection, the rates of testing. And so whenever you calculate a rate, you need a denominator. And in this case, that denominator is a population, or maybe it's something even more specific. That denominator could be the population of a specific demographic. And so while that's a real simple example, it's an example of analysis that would have been difficult even a decade ago. Right now there's just more data out there, for sometimes for free, but also for fee or for syndication, for companies to augment their internal data with very, very rich external data.
That's interesting. You're relating things back to reports. We've all been watching closely, but isn't the fact that the general public's become a consumer of analytics interesting unto itself right now?
I certainly do think it is. Good question. I think you touched upon one of the most positive impacts of what's going on right now, at least short term, is you hit the nail on the head. Unknowingly, the general public has become accustomed to looking at reports to kind of figure out what's going on in the world. And more specifically, they've unknowingly embraced the notion of predictive analytics and what if scenarios. So think about those graphs that that people are looking at all the time now. I mean, there's different trajectories on there. Each one of those trajectories is a different what if scenario. And by the way, the path of those trajectories, that's machine learning and advanced analytics. So right now we've got a wide scale adoption of those two things that were kind of taboo not very long ago. And that's, if there is a positive thing about culturally what's going on about this current situation, it's that we've totally taken a quantum leap leap in data literacy across the world.
So if the general public's consuming and expecting advanced analytics in their day-to-day personal lives, what about their day-to-day lives at work?
So, okay, yeah, advanced analytics at work. Yeah, that's a fair question. If people are expecting to log on and read the news and see advanced analytics, even though they may not know it's advanced analytics, that's how they're expecting to kick off their day. Why would they not expect to kick off their day the same way in a professional environment? So, I'd like to point out something that's a little bit controversial, although it probably shouldn't be. I contend that with the exception of data scientists and some academics, that people don't actually care if what they're looking at is advanced or traditional or predictive or prescriptive. Assuming they have trust in the data, they don't really care what machine learning model was behind the scenes, or if it was even machine learning at all. And going back to those reports that the general public is consuming daily, I think that's a good example. People just want answers. They just want to kind of get a handle on what's going on around them. So, I think there's a lot of advancements in recent years that the modern front-end analytical tools have blurred the lines between traditional and advanced analytics, and that's a good thing. When you look at a dashboard, for example, that has some machine learning baked into it, there's not a title above that graph and chart that says, hey, here's machine learning, or hey, here's advanced analytics. It's just blurred together, and that's a really cool thing. And industry pundits will call this augmented analytics. And again, while I agree with this notion, and I really love that term, I don't think end users really care. But while I'm on that point, I'd like to also point out that while the front-end analytic vendors, like the dashboard vendors and the front-end analytic tools, that they've done a good job about blurring the lines, so have equally the downstream vendors farther down the stack. So, I'm talking about like database vendors who have done a really, really good job about, exposing some really powerful machine learning algorithms, and you can just hit them with SQL. That's super, super exciting, because ultimately what that means is companies and users, it's easier to arm them with better and better analytics.
So for those of you that don't know Patrick, he's a really humble guy. He's so passionate about his field that he exercises his right to sometimes hit the soapbox. So, okay, I understand that people may or may not care, Patrick, about labeling their analytics. But back to the original question, will the general public grow to expect better analytics to make more informed choices and decisions at work?
Yeah, thanks for getting me off the soapbox and back to point. So now that I've emphatically said that users don't care if they're using traditional or advanced or augmented, now I got to be careful to choose my words wisely to describe things. So for the sake of discussion, let's use the term embedded or enhanced analytics as an umbrella term to describe these improvements. So a lot of industries have been using enhanced analytics for quite some time. So some industries have always been on the bleeding edge of analytics, specifically like banking and FinServ or financial services, insurance companies. Companies like in industries like that have employed the most powerful analytics available at the time. So, some examples there within financial services, we have bots. They're commonly referred to on the street as algos. If you ever watch CNBC, these algos or these bots, they're looking for trends in the equities markets, and these bots will go out and identify areas of opportunity and risk. Then they actually automatically will execute trades once they, once they find something that's really interesting to them. These types of companies, they've also had statisticians, or you may have heard the term quants. They've had these quants on staff to perform these one-off analyses for years. Anybody who's gone through some sort of machine learning class at some point, that you probably know, you've probably seen an example where somebody wants to create a model to predict and score potential lendees' creditworthiness. But the fact is we are seeing, and it should not be a surprise, that we're seeing more and more types of these advanced analytics used and not actually demanded by companies and other industries. And the users that are demanding these, they're not data scientists by trade. So companies know they have to squeeze as much out of their data as possible in order to remain competitive. I mean, companies know that if they don't find insights in their data and use that to run better, one of their competitors will. So it's almost an arms race within the data and analytics world, and that's and the cool thing is everybody wins in that. The world benefits when things are running more efficiently and people have more access to good data. You know, when I'm talking about this, I realize that I'm making this whole advanced, and I'm actually trying to describe the opposite, but I'm afraid, as I've talked about this, that I'm making advanced analytics seem very mysterious and difficult, and sometimes it is. Sometimes it does mean developing very complicated, very customized, and use case specific machine learning models. But that's not always the case. And so, you know, let me give some examples of where, you know, companies have done a good job about blurring the lines. So if you've ever seen natural language search baked in the front ends of analytics tools these days, and that's almost like a Google for your data, that's definitely a really good and approachable way of using machine learning and AI to query your data. If you've ever seen any natural language generation where it'll highlight pockets of opportunity and present results in natural language, that's another good example. You know, people don't, there's a whole lot going on behind the scenes there, but it's really exposed in a really nice, clean way. And you know, another example there is if you've ever seen tools that will aggregate or will cluster or group your customers together, you know, put them in nice groupings, and then you can report and aggregate data across those groupings. Those are all really good examples and very approachable examples of advanced analytics. I mean, heck, even anybody who's used a basic trend line in Excel, that's an example of an unsupervised machine learning model. I mean, and that was just a simple right-click operation, and so this kind of goes back to my point. You know, advanced analytics is the lines are getting blurred. It's getting more and more ubiquitous. And at the end of the day, people don't really care what the label is. And I think a lot of this is because the vendors are getting very, very good about blurring the lines, and that's a good thing.
So above and beyond the blurred lines that you speak of, I've had many conversations with companies who are looking to make the jump to true data science. But when I talk to the data scientists, you included, about things they're seeing and working on, their knee-jerk reaction is to cringe because they don't trust the data that these companies have. What's up with that?
Yeah, I think there's a couple levels of mistrust in data there. So let me start my answer with something a little bit controversial again. And it goes back to data prep. So with data prep, and more specifically with the exercise that leads to good, clean, reliable, and analyzable data, while that's arguably more important than the models that data scientists put together, data prep is usually the least favorite part of a data scientist's job. They don't like it. They'd rather be building models, and candidly, that's what they should be doing. That's what they were paid to do. They weren't paid and hired to munge through data. And I'll expand upon that. I'll also contend that data scientists aren't very good at data prep. I mean, data prep isn't typically part of their formal training. I mean, yeah, there's a few data prep libraries that they like to use, but they often don't have access or even know how to use enterprise strength data prep tools. And even if they did, they simply don't have the years of experience of building data stores and the subsequent data models and semantic layers on top of them, like a traditional ETL developer would. So, you know, I contend it's prudent and it's incumbent upon an organization that ensure the data scientists, well, all analysts for that matter, to begin their analysis working from a strong data platform and foundation. And if you're going to have a strong data foundation, you need to really have a good, broad understanding of the source of data across your organization. You need to know, for example, where to store the data, how to store the data. You have to kind of know a little bit about what types of analyses may be performed. That's going to kind of lead you to decisions about what data needs to be warehoused versus what needs to be in a data lake. And those are there are experts out there in the industry that will do this for you so you can make sure your analysts, data scientists included, can spend their time analyzing the data, not organizing and wrestling with it. And so, I think there's yet another part of this answer. Why do data scientists groan when they start talking about source data? Let's assume for a second that a data scientist does have a good data foundation to start with, and he's got perfect data. The problem that a lot of data scientists will run in is, they may develop the most perfect model with the most perfect data, but there's going to be distrust out there because the people don't trust the source data. They didn't get buy-in up front. And that can be really frustrating for a data scientist, but also for any analyst. I mean, how many of us have on this call? I recognize a lot of names on the list today. We built a real simple pie chart, and we spend hours arguing about the pie chart because there's not buy-in on the data. And I think that's a good reason why one of the most important offerings that we have to offer here at Analytics8 is our data assessment and then the subsequent implementation of a data strategy. This is already getting to be a pretty long-winded answer, so I'll just go ahead and point out that we're actually doing a follow-up webinar in a week that talks about just data strategies. And so I'd encourage everybody to join that one now. We'll spend quite a bit of time talking about that. But the key for now is establishing buy-in up front and then ensuring that buy-in remains intact as your data platform grows.
Okay, so I get the importance, and I know we're going to be talking about it next week from a strong data foundation. But for some companies that are out there that do have that strong data foundation, some of their data projects, their data science projects, still fail. How come?
Well, I think it's more than just some projects fail. I mean, it's estimated that 85% of data science projects fail. And we've already established that data scientists can build the perfect model with perfect data, but people aren't going to trust it if there's not buy-in up front. So to speak to your point, what if there was buy-in up front? And what if they were dealing with the strong data foundation up front and they didn't have to deal with that cultural battle? It's hard to know how much of that ghastly 85% failure rate is due to poor data foundations or not, but safe to say that there's some. So I think this goes back to just good project management, and that's not, some of it's not even unique to data science rollout, and that's properly define your goals up front. Make sure we know what we're shooting at, and if we hit what we're shooting at, are you culturally ready to take action upon that? Some organizations simply aren't ready culturally to trust the results of a model. Another mistake that people make is, and this sounds basic, but we see it time and time again, is this machine learning project, is this going to be a one-off, kind of like a science project, or is this something that we want to have operationalized and use over and over and over? And I think there's another really thing it's not popular to talk about, but there's a very broad misconception out there that data is always predictive, but the reality is sometimes there is no signal in data. You can have the world's best machine learning model, but if the data isn't predictive, if there really can't, there's nothing to say. There is no edict out there that says all data must be predictive. It's just not. And if it is predictive, it could be could be predicted without a strong level of confidence. So that's another mistake that people will make up front, is going too far down a path and then discovering later that even their data, albeit perfect, is not predictive. And I think that's why another really important offering we have here at Analytics8 is our data science readiness assessment. We kind of go through all these things, make sure you don't get too far down a path, make sure you've got your data in place, make sure you're culturally ready, but then most importantly is make sure what the target you're trying to hit, make sure it's hittable. One thing before I wrap on this, because I'm going to go back to my soapbox here for just a moment. Of all of the reasons I talked about why a data science project may fail, you may notice that not a single one of them was because the accuracy of a model was bad. If the accuracy of a poor model is typically not a reason why a data science project will fail. I mean, model generation now is even becoming commoditized. I mean, it's automated. That's not typically the reason it is. It's because of the other things I talked about up front. There's not buying in the data. People aren't culturally ready. You didn't properly define the goals up front, or the data itself, albeit perfect, does not have any signal. Does that make sense?
Yeah, yeah, absolutely. Well, thanks. And let's try to move to, if you're okay now, to take another sip of water and maybe take a couple of questions from the group. So if anybody wants to add a couple of questions, we've got a few down here. And I'll start with the first one by asking, this is coming from I can't see the title, but somebody working for an 80,000 employee company that says they're having trouble getting their executive team to get on board and stop making their decisions off of Excel spreadsheets. What do you have to say about that? I've heard that one quite a bit myself.
Sure. Well, I've actually had conversations with you about that with you in a former life at a former company. And, you know, I think this one's pretty simple, is where's your time better spent? Is it spent creating manual reports, or is it better spent driving the business? I mean, I think that's a pretty easy answer there.
Let's take a look at the next one. What about this is somebody asking about what if we have a strong data foundation and we're not sure of our capability. We think we have a good reporting system in place. And I kind of understand
I think that's a really
there.
Yeah, I don't know if the person who posed that question intended to have you put the accent on that nuance, but I think you know, the term think. I think that's the key word there, and I think there's a great follow on to the former question. Is, you know, the big assumption here is you've taken the leap and you've automated reporting, you've automated data loads, and you're confident in the numbers. But again, is your time better spent analyzing reports, or is it time to take action on them? But going back to that word you said, think. Are your reports actually good, or is there room for improvement on there? I mean, we're going under a strong assumption that analysts out there, they're fully aware what actually is possible. You know, we talk about the art of the possible, but I think it's good to revisit what other people are doing out there. What other bells and whistles do modern tools have to offer? What are other people in similar industries doing? And then I think we also have to go back, what must be done to arrive at this report? I think people automatically assume they've got the most perfect streamlined case of loading their data and getting from point A to Z, but I think there's always room for improvement all across the board.
Yeah, well, let's see. Let me see one more. Any tips, Patrick, for staying up to date on the latest analytic trends?
So yeah, I saw that one. I don't have a whole lot of favorites. Harvard Business Review is a good one. I've got a few. I'm drawing a blank. I have a few go-to ones. The Economist has a good one. They usually have a lot of good articles.
Yesterday. I can't remember which one.
Yeah, Forrester has one. Yeah, of course there's Forrester, and then there's Gartner as well. Those are good for people who may not be as well versed on the technical aspects of the tools. I really like kind of the more higher level ones like Harvard Business Review and The Economist, because they kind of don't get so far in the weeds technically and talk about the applications to industry.
Yeah.
And so I kind of like to have a mix of the two.
Let me kind of wrap this up with one more question, Patrick. Can you talk a little bit more? I know we talked a lot about the cloud, but can you talk about some of the risks of going to the cloud?
Okay. Well, implied in that question, and I hope that means that I've already made the case for going to the cloud, and whether or not I've made the case, customers are doing it in mass. So I think that's a fair question. So of course there is risk of doing anything, including going to the cloud. I think it goes back to some misconceptions. One is that people think that server administration and that disappears. You know, that's mostly true for PaaS and SaaS. You know, for example, if you are Snowflake, you don't really care. If you're a Snowflake customer, you don't really care about what platform it's running on, and you don't have to worry about patches to the online platform. But when we start talking about infrastructure as a service, like, you know, getting an Amazon EC2 instance set up, or any of those things, there is still server administration. So I think there's a big misconception there, and people don't plan accordingly. People also think that security concerns disappear. It's like, hey, you know, Amazon's better at, and Microsoft's better at security than I am, so I'm going to adopt their cloud platform and I don't have to worry about security anymore. That's not true. So they take care of patches and hardening the environments, and they watch for network intrusions. But it's your responsibility to take care of user administration, and often it's your responsibility to take care of authentication. So when you hear about these security breaches out there, it's because people have left things open by accident, or they left some backdoors open that were their responsibility. So, but I think one of the biggest risks is financial. You know, I think that it's wasted spend, more specifically. So usually there's a lot of low-hanging fruit in your cloud environment that you can prune. So, for example, we recently worked with a customer who had a bunch of stuff across all three of the major platforms, AWS, Azure, and GCP. And we went in and worked with them, and without making any like super radical changes, we trimmed off $50,000 a month from their cloud spend. And we did that just by auditing their bills and looking at their usage. I mean, this is a pretty quick in and out that we did. And I don't care how big of a company you are, $50,000 a month savings that's huge.
That's impressive and significant. Well, thanks for your time, Patrick. I think this information has been beneficial to so many during these unique times. And thank you all for taking the time out of your day to join us. I want to remind everybody that we'll be emailing you a link to the recording of this webinar in case you want to listen to it later or share it with any of your colleagues. And that concludes our discussion for today. Thanks again, and have a great day.